Today in playing with fractions, we are going to add and subtract fractions with different denominators. Now, how do we do that? Well, the first thing we need to do is get our denominators to be the same. So we are going to find the least common denominator that will work for the fractions we're playing with. Then we'll need to convert each of our original fractions into an equivalent fraction using that new denominator. After we have the same denominators, we're going to add or subtract the numerators. We'll keep the denominator the same, which of course will be our least common denominator. And then we will simplify the fraction if needed. Let's jump in. We're going to add 7/12 plus 5/18. Now, easy to see, 12 and 18 are different numbers, and we need to decide what is the common denominator. There are a few different ways you could do it. My way that I like to do it is to say, okay, 18 is the bigger of the two. So I'm going to list my factors of 18 and see which one of those does 12 go into nicely. So I have 18, and then 18 times 2 is 36, times 3 is 54, 72. I can go on and on and on. But hopefully I see pretty quickly that 12 goes into 36 3 times. So my least common denominator is 36. So I now want to write a new fraction problem where each of my denominators is 36. So think about the process for this. In our first fraction, 12 times 3 gives us 36. Therefore, my numerator will also be taken times 3. So 7 times 3 is 21, right? Equivalent fractions. In my second fraction, 18 times 2 gave me 36. So I take my numerator times 2, and 5 times 2 is 10. Once I have my equivalent fraction, I'm ready to add. Remember, when we add fractions, our denominator stays the same. I add my numerators, 21 plus 10, and I get an answer of 31 over 36. Those two numbers share no common factor, so there's no simplifying needed. And my answer is 31 over 36. So thinking through the process, remember you can also find the least common denominator by breaking down, there we go, by breaking down the the denominators into 12, breaking it down to product of its primes, 2 squared times 3, and 18, 2 times 3 squared, and then taking the common multiple from there. And that's where you get 2 squared times 3 squared, which gives you 36. So we talked about least common multiples in a different video. Same process if you wanted to do it that way. I just like to make sure you know that you have options. Okay, let's do another one. 19 over 24 minus 7 over 15. Now, 24 and 15 are not as nice in terms of listing them out. You can do that way, which is, my preferred method of 24, 48, 72, 96, 120. But as the numbers get bigger, it gets a little more difficult. Now, 120 is our common denominator, but if you don't see it this way and you'd rather break it down into the product of its primes, let's look at that way as well. So 2 times 12, 12 is 2 times 6, 6 is 2 times 3. So 2 cubed times 3 gives me 24. Next, if I go to 15, that is 3 times 5. Okay, so our common multiple, or least common multiple, you're going to need all of the prime numbers to the highest exponent. So I'm going to need 2 cubed times 3 times 5, which happens to be 120. So my common denominator for these two is 120, whether you do the listing piece or breaking down to a product of its primes. Okay, so now that we know that our common denominator is 120, you might need to say, okay, 24 times what gives me 120? Well, if you don't know that, you can divide. 120 divided by 24 gives me 5. So my first fraction needs to be multiplied by 5 because 5 times 24 is 120. So 5 times 19 gives me 95. And my second fraction. 15 times 8 gives me 120. So 7 times 8 is 56. Okay, perfection. So now when I subtract those, my denominator stays the same, and 95 minus 56 is 39. Hopefully the alarm bell will start going off for you, and you notice that 39 and 120 are both divisible by 3. They share a common factor of 3, therefore we must simplify. So 39 divided by 3 is 13, 120 divided by 3 is 40, and there is my simplified fraction. So 19/24 minus 7/15 is in fact 13 over 40. All right, how about you try one? Let's go into a story problem. You try it, come back. Jessica is making covers for the throw pillows on her sofa. For each pillow cover, she needs 3/16 of a yard of print fabric and 3/8 of a yard of solid fabric. What is the total amount of fabric Jessica needs for each cover? Okay, with story problems, you have to think through a few things. We know she needs 3/16 yards of print, 3/8 yard of solid, and the question is, what's the total amount needed? So that means we're going to add. We're going to take our print fabric and add our solid fabric. Hopefully then you say, this is an adding of fractions, I need common denominators. 16 and 8. Well, I see right away that 8 is just times 2 to get 16. So my common denominator is going to be 16. The beauty of this is my first fraction stays the same. There's no change in the denominator, so no change in the numerator. In the second fraction, as mentioned, 8 times 2 gives me 16, so 3 times 2 gives me 6. Once my denominator is the same and I've made my equivalent fractions, 3 plus 6 is 9. So Jessica needs 9/16 yards of fabric for each pillow cover. Hopefully that helps you understand a little bit about adding and subtracting fractions with different denominators.